Hello, we continue with section 5.1. In the last video, I showed you that given a curve and we need to find the area under the curve, then we can do that, or we can approximate the area under the curve by using rectangles with heights determined by either the left endpoints of interval subintervals or the right endpoints of the subintervals. So then have uh, have the left subintervals, then our sum of areas of rectangles is given by this formula here, which then can be written in the compact form as that formula, the summation sign. And if we have the right endpoints, if we are using the right endpoints, then we have the formula given here, which can be condensed in the summation form like that. We also notice that as we increase, if we increase the number of rectangles, which means we increase n, and then the width of this rectangles gets smaller and smaller, and but we also notice that we lose less and less area, or our approximation becomes better and better for the area. So that in the limiting case, when n goes to infinity, the sum Rn, the right Riemann sum, as n goes to infinity, becomes equal to the area. In the same way, if we were using the left endpoints, then the same way, the limit as n goes to infinity will become equal to the area. So now we use this intuition to define what do we mean by area under area of a region under a curve, or how can we find the area. So it says the area A of the region S under the graph of the continuous function f is the limit of the Riemann sum. So now we are defining the area as the limit of the Riemann sum. So which means A is equal to limit of R sub n and goes to infinity, but R sub n is what we have here. So it will be limit as n goes to infinity of the summation of f of x k delta x, where k goes from 1 to n. Or the same way we can say the area becomes equal to the Riemann sum in the limiting case, as limit as n goes to infinity. But now here you can see the indices have different values. In the first case, k went from 1 to n. Over here, k went from 0 to n minus 1. We can rewrite this summation, this expression, by changing the values and the index n. Also look at the x k is replaced by xk minus 1. Because remember, what you want here to come in here is, in both cases, should be the same, because they are approaching the same area or same value. Now we could also do this approximation by finding the areas of the rectangles and adding them up when our height is taken at the center or at the midpoint of the interval. So first we find the midpoint of each interval. Remember, we had n intervals with endpoints x0, x1 for the first one, x1, x2 for the second interval, x2, x3. These are the endpoints. So now we want to find the midpoint. Now if this is an x minus x sub k minus 1, and this is the point x sub k, then the midpoint is going to be something here. And the formula, in order to find this, what we do is, so let me say xm will be equal to No, I will not call it x. We call it cm, c1, right? So cm, ck, sorry, ck. Okay. So this is x sub k, and the previous one will be x sub k minus 1. Okay. So now what is ck? So ck will be the sum of these two. So x of k minus 1 plus x of k sub k.
What can I help you with?
Alexa, stop. So we find that C1, C2, C3, and so on. And now what will be our approximating sum? So this will be now f of C1 plus f of C2 plus f of C3 plus dot 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 plus f of Cn multiplied by delta x. So I skipped one step here where we were writing f of c1 times delta x plus f of c2 times delta x and so on. You know already that delta x will eventually come out. This can be written as, well, it's hard to put it in the summation form. Why? Because remember here, well, not really. So let's try it. So summation f of ck delta x. But where k is going from 1 to 1, not too bad. Okay. So this is also, if we take the limit, this will also give us the area. So now look at some concrete examples. So here, the first example I have here is saying, consider the function f of x is equal to sine x. Estimate the area under the graph of f of x is equal to sine x from x is equal to 0 to x is equal to 2 using 4 rectangles, approximating rectangles. And what else? Right endpoint. So using 4 rectangles, which means n is equal to 4. And then right endpoints, we know how to find the endpoints, and then when we write our sum, depending on we are doing it for finding the right sum or the left sum. Accordingly, we will choose the values we will pick from there. So let's start, and it's also sketch the graph of graph and the rectangles, and then is your estimate and underestimate or overestimate. Okay, so we can start by finding the delta x first. So what is a here? A is 0, b is pi over 2, then n is 4. So the delta x, which remember is b minus a over n, so pi over 2 minus 0 over 4. What does that give me? Pi over 2 over 4 is equal to, what is it equal to? Is it equal to 2 pi? No, it's not 2 pi. It's going to be pi over 8. I hope you guys can see that. That's a pi over 8. We'll leave it like this. We will not convert it into decimals yet. Okay, so now I have to find the tick marks. So x sub 0 is equal to 0 is equal to a, which is equal to 0. X sub 1 will be equal to 0 plus delta x. So 0 plus pi over 8, which means pi over 8. And now actually I can use that formula that x sub k is going to be a plus k delta x. So x sub 2 will be 2 pi over 8 or pi over 4. X sub 3 will be 3 pi over 8. X sub 4 will be 4 pi over 8, 4 pi over 2. And it should be pi over 2 because it is actually x sub n. If 4 is n is equal to 4, so this is the same thing as x sub n. Okay, so now in order to find the approximating sum using the right endpoints. Where will we start? We will start at x1. Start here and have all these in our sum. So r sub 4. So basically we are calculating r sub 4. So r sub 4 will be f of x1 plus f of x2 plus f of x3 plus f of x4 times delta x, which gives me sine of pi over 8 plus sine of 2 pi over 4 plus sine of pi over 8, 3 pi over 8 plus sine of pi over 2, and we have to multiply this whole thing by delta x, which is pi over 8. Now, a very important thing here, when you are doing problems of this type, you must make sure that your calculator is in radian mode, not in degree mode. Okay? So now take your calculator and write down these values. So I have 0. If sine of pi over 8 is going to be 0.3827 plus sine of pi over 4 is 0.7071. I'm just going to 4 decimal places just to make sure that we are not losing too much value or too much area. Then the next one is sine of 3 pi over 8. So sine of 3 pi over 8 is 0.9239 plus sine of pi over 2 is 1 times pi over 8. So multiply all this together and you get 1.1835. Well, I hope you guys got it. Next one. So, sketching. Sorry, sketching is left. So how do we sketch and how do we? So we have 0, and let's say this is pi over 2. Actually, yeah, this is pi over 2. I'm just going to go from 0 to pi over 2. So this is 1, right? So remember the sign is equal to 1 at pi over 2. So sine of pi over 2 is 1. So it means at pi over 2, we will be at 1. And at 0, sine is 0. Now sine function doesn't go like that. Okay? That's more like a parabola or a square root function. Sine goes like this. There is a little bit bend in the curve in the middle. So this is how the sine is looking. And you divide it into the subintervals, because that's what the question is asking. Sketch the graph and the rectangle. So rectangles also. So in this case, we have to split at where will be pi over 4. It will be in the middle. So this line, and then this will be 3 pi over 8, and this will be pi over 8. So since we use the right endpoints, so our rectangles are going to look like that. Okay. So what do you see here? We are getting extra area. So this is a upper estimate. So next is we are going to look at the same situation but from the left hand points. So what will be the figure like? This is our graph, and now I have to make the divisions or the, but we will be using the left points this time. So first we'll partition at the center, pi over 4, then half of it here, and then half of this side will give me the 3 pi over 4, 8, sorry, 3 pi over 8, this value. And then on this side I get pi over 8. Okay, so the left hand points, we find L4, which is going to be now. So now we will start at x sub 0. We'll start with this. So we will have sine of 0 plus sine of pi over 8 plus sine of pi over 4 plus sine of 3 pi over 8. And then we also have to multiply it by pi over 8. So sine of 0 is 0. So this is gone. Sine of pi over 8 is, I can use the numbers from the top. So 0 plus, I'm putting the 0 so that we know the number of terms is correct. Because if I don't put 0, there will be only 3 terms you will see. Sine of pi over 8 is 0.3827 plus sine of pi over 4, 0.7071 plus 0.9239 and then multiplied by pi over 8. So when we do the calculation, we end up getting 0.7908. 7908. 908. So this is the lower estimate. Or underestimate. Okay, so in the question it says overestimate or underestimate, which is the same thing as lower estimate here and then upper estimate here. So same thing. So this is how we do these problems. Let us look at another example. Actually, before I do the example, we now know how to deal with the area problem. So how about the distance problem? So we will notice that it is similar. Basically, it's the same kind of problem. So, but was the posed question? The posed question was to find the distance traveled by an object during a certain time period if the velocity of the object is known at all times. Now, known at all time doesn't mean that it will be the same at all times. It could be changing continuously. So it means the velocity could be a function of the variable t of time. So if so we can easily calculate. But if the velocity is changing, then it is not that easy to find the distance traveled. So we notice here that actually finding the distance is the same as finding the area under the curve. So now this time the distance, the curve that we are talking about will be the velocity function. And actually there are other quantities in natural and social sciences that can also be interpreted as the area under the curve of a graph. Some examples are work done by a variable force, cardiac output of the heart, and amount of oil leaked from a tank. So these are some examples. There are others as well. So let's look at the next example. It says find the velocity of a graph of a velocity graph of a car accelerating from rest to a speed of 120 kilometers per hour over a period of 30 seconds is shown. Estimate the distance traveled during this period with okay with nothing. They didn't give us anything, but I will we will ourselves decide how many sub intervals we want or what n should be, and then we will do the problem with both with the left hand and the right hand. So note here, starting from rest means what? At rest, v is equal to 0. Velocity is equal to 0. Now, so that v sub 0, t sub 0. Velocity is a function of time, remember? So that at t sub 0, which is 0, so at time t is equal to 0, v is equal to 0. So v to a speed of 120 kilometers. So this is basically t sub n at, so when t sub n is equal to 30, v is equal to this much. Okay. Again, we can, the previous example that I showed you, we had this one. So we were given a function. So this problem can come in different forms, but basically asking you to do the same thing. So here we were given a function and we're given the interval. And of course, we were told how many intervals we should divide in or how many rectangles we should use. In this case, we are not given how many rectangles, but we are given just the graph. So what I can do is I can first make a table of values. So n, let us take n to be 6 because it makes sense. We have 3 values given here at the base. And we will be and the half the distance of the between the two points, 2 tick marks. We have another grid that will give us can easily get the value of the function from there. So let n be equal to 6. So the interval is from 0 to 30. So t is from 0 t is equal to 0 to t is equal to 30. So our a will be equal to 0, b will be equal to 30. We have to be a little bit careful here. Let's first do this. That b is equal to 30 and a is equal to 0 means delta t will be equal to b minus a over m. So will be equal to 30 minus 0 over 6 or 30 over 6 or 5. 5 what? 5 seconds. But notice here, our V is given in kilometers per hour. Kilometers per hour. So we are not, don't have the same unit. So it means one of the quantity, we have to convert the units so that they match the other units, the units of the other quantity. So since we have kilometer per hour here, it will be easy for us to change the 5 seconds into kilometer. So how many, into hour, seconds into hours. We can't change time into kilometers. 5 seconds to whatever hours. How do we do that? Well, because we are going to a higher unit or bigger unit from the second, we have to divide. So in a second, in 1 hour, there are 60 seconds. In 60 minutes, and then in 1 minute, there are 60 seconds. So it means if I divide the 5 by 60 into 60, which is going to give me 1 over 720, so many hours. So this is our delta T. Now let's make it, either we can make a table or we can just list. It's your choice. So if I make a table, this is my T and this is B. Now this is, remember, in hours, and this will be we don't need this. We can do without this. I think that will be easier. So what will our T naught is zero. T1 will be 0 plus delta T, which is 1 over 720. Oh, I think let's keep it that way. And let's keep it like this. At 0, this is 0. At 5, yeah, let's do it this way. So these are in seconds. T is in seconds. And B is in kilometers per hour. 5 at 5 the value is at 5, this will be 5, the value is here. What is that? How will you read that? This is about 50. So I'll say 50. At 10, the value is over here. So what is that? Almost 80. Or if you want 79, it's your choice. But if you write like 20 or 25, that will be wrong. So your estimate should be very close to what anyone can see. So I'll take it to be 80. Then at 15, so this is clearly below the horizontal line of 100. So I'll say it is 80. This was supposed to be 100, close to 100. So I say 98, 20. At 20, the value is 110 or 105, you can say. It's your, again, it's not maybe in the middle, a little bit below middle, then you can say 108 or 25. So it is close to 120, so let's say 118. And then at 30, we have 120. So now, if I want to find the R sub n, so if R sub 6 will be equal to. Now I'm going to add these 6 quantities, or these 6 values. I get 50 plus 80 plus 98. Below, because it will otherwise clash with that. 98 plus 110 plus 118 plus 120, and then we will multiply the whole thing by 1 over 720. 720. So what do I get? So I'm getting 0.786. This is what I get. Now making this table is a good idea, because when you write these numbers, we can see where you're taking them from. Instead of directly every time checking our number matching with this table is a good thing to do, and it can be done for any problem in which you have to find these sums. What about R sub L sub 6? That will be equal to, now we will start with the first quantity, which was 0. So we have 0 plus 50 plus 80 plus 98 plus 110 plus 118. Should I say plus 120? Okay, before you write it, first let's count. So 1, 2, 3, 4, 5, 6. We have 6 terms or 6 numbers being added, so we are good. We cannot have the last one. Remember, we start at xk minus 1 or xn minus 1. So n is 4, so 6, so 6 minus 1 is 5, so this is the x5 that we are stopping at. And then we multiply it by 1 with 720. So what do I get? So now I'm getting 0.6194. So what did the question ask? It said estimate the distance traveled during this time period. So from here, you can see this is the distance, or this is the distance traveled equal to 0. You can say 0.8 what? Kilometer. Because remember, we have kilometer per hour, that is our velocity divided by our rate. That is the unit of the velocity, and we are multiplying it with the unit of time, which is we converted into hours. So we multiply this by h. So h and h cancel out. We are only left with kilometer, km. So we have the distance traveled is 0.8 kilometer, or you can say 0.79 kilometer, or you can just say 0.786 kilometer. Okay, let's look at one more example. It says oil leaked from a tank at a rate of RT. So RT is the rate, liters per hour. So liters per hour, that's the unit. The rate decreased as time passed, and values of the rate at 2 hour time intervals are shown below. So notice here time is in hours. At 0 hour, 2 hours, after 2 hours, 4 hours, after 4 hours, which means the distance of this and this is 2, and then distance of this is 2, and this is 1. So our delta t, you can see from directly from here, you can say delta t is equal to 2. Even if you do it b minus a over n, you'll get the same thing, because what is b here? This is a and this is b, and we are dividing it into 1, 2, 3, 4, 5, 6. So we are dividing it into 6 sub intervals. Or actually, this has been divided from 0 to 10 hours, has been divided into 6 sub intervals. Okay. So how we start? Lower estimate and upper estimate. So our delta t is 2. Our, you can see these values. So this will be the value of f of 0. This is f of 2, and so on. We don't need to write that. We can directly say r sub 6 will be equal to, remember, we will leave the first value and start with the second value. 7.6 plus 6.8 plus 6.2 plus 5.7 plus 5.3 whole multiplied by 2. So that gives me 60. So 60 what? 60 liters. That gives me the amount in liters, because the unit of time, hour, and hour they cancel, and L6 will be equal to, so now we will start with the first value but stop at the second last. Stop here. So we have 8.7 plus 7.6 plus 6.8 plus 6.2 plus 5.7, and we stop, times 2, and this gives me 70L. So this is your upper estimate. One is upper, one is lower. The smaller value is the lower estimate, and the higher value is the upper estimate. So this is how we use the Riemann sums.